Hey everyone, welcome back to Model with me. I'm Yusuf and today we are going to be going through problem 2 of section A from the SolidWorks CSWA prep exam. If you don't yet have this PDF, you can get it from the link in the description of my intro video for this playlist. So getting straight into it, let's go through the question. Part A. Build this part in SolidWorks. Use the values below as needed, then find the mass of the part in grams. Okay, so they give us the unit system to use, the number of decimal places, where to place the part origin, material type, material, and the density. Hint, this part can be built using only 3 features. Okay, so we got some steps, some angles, and some extrusions of those angles. So let's get straight into it. One thing to note though, today I've managed to find myself a key tracker so that you can keep up with my keystrokes and see which shortcuts I'm pressing. I don't have the standard shortcut set up. I have mostly custom shortcuts set up, but just so you get an idea of what I am pressing when I'm working. So to start this off, I'm going to start with the outer dimensions that were given. So going back to our PDF, we have a dimension down the bottom and a total height to the apex, which we're going to use to construct the rest of it. So heading back to SolidWorks, let's first go ahead and rough out our shape. We're going to assume that these two are perpendicular because no other information is given. We have our cutaway in this region somewhere, also perpendicular. We know that these are going to be parallel, and for now that's about it. So let's go ahead and dimension our outer shape. 78 and 58. Ooh. Okay. Interesting. Okay, heading back to the PDF, let's check out our other dimensions. For our cutaway depth, we have 36 for the depth of it. The width of it would be 5 and 15 from the angled face. Our angled face sits at an angle of 65 to the horizontal, and our midpoint here would be the midpoint of the bottom step, which has a height of 16, so naturally that's going to be 8. So let's go ahead and put all that in. $65. 36. 5. 15. A height of 8. The last thing we seem to be missing is where this line would sit. So we don't have a depth. What we do have are the dimensions of our steps. So we can model those in and use those to reference off to get our sketch fully constrained. So let's put in some construction lines. Let's check our dimensions. We have our height of 16 for the first step, 18 for the second step, 24 depth for the first step, 16 for the second. Heading back to SolidWorks, 16. This one seems to have been constrained to the margin. 18. 24. And finally 16. So our sketch is now fully constrained. We can go ahead and extrude it. Selecting our region that we want to extrude, let's check our extrude depth. We have a depth of 28 to extrude to, so let's do that now. 28. Feature 1 complete. The next step, you could do either those two protrusions on the top next, or the two steps next, as they're both unrelated to each other. I'm going to choose to do the two steps next, but it really doesn't matter which one you do first. So doing the two steps next, we know that the two steps are flush with the back face of our part. So that's where we're going to put our sketch, just for simplicity's sake. You could put it on the front, but then it's an extra step to define where from and where to. So let's go ahead and do that now. On our back face, let's rough out our shape, then close our sketch, and we can add in dimensions. We actually already did add in dimensions, so we could just use the same dimensions from the last one. So these ones we know are already constrained and dimensioned correctly, so we could use those. You could dimension them separately if you wanted to, but either way there's not really much of a difference, except when it comes to editing the parts later on. So we can go ahead and complete that and extrude. Change direction, and let's check our depth. So that's going to be extruded to a depth of 18. Heading back to SolidWorks, 18, and we can confirm that. Let's hide this sketch again. Then lastly, we have the protrusions on our top face. So let's go ahead and do that now. Let's check our dimensions first and where it sits. So the width across our step or across our surface is 15, and the center of our circles lie along the center line 7.5, and they both equidistant on both sides, 7 and 7, with a diameter of 6 each. So let's go ahead and do that now. We have 7 mils there, another 7 mils to the midpoint on that side. So let's equate these two. So we only have one dimension to modify if there is a change. 7 millimeters with a diameter of 6. So again, we are going to equate these two. And lastly, to extrude. Going back to our question, it needs to be extruded to a depth of, or height of, 6 millimeters. So let's do that. 6 millimeters. And our model is complete. Last thing to do is to apply our material and check our mass. So applying our material, ductile iron. Let's check our density. We needed a density, according to the question, of 7,100. This would be the correct one. Let's apply that now. Material applied, we are now ready to check our mass and compare it to the solution provided. So our mass comes to 497.28 grams. Let's compare that to our answer. 497.28 grams. Brilliant. Let me know in the comments what you guys got. And also, if you have any other suggestions or feedback, I'd love to hear from you as well. And if you found this video helpful and you'd like to see more, please consider subscribing and liking this video. And I hope to see you guys in the next video.